Instantaneous acceleration. Instantaneous acceleration. For that, we can draw velocity time graph of a body moving with uniform acceleration. Sorry, not uniform, non-uniform acceleration. That's why the graph will be a curve, not a straight line. And we consider 2 points A and B on this velocity time graph. So A and B are the 2 points on this velocity time graph, and the vertical axis is the velocity axis. Velocity is plotted along vertical axis and time is plotted along x-axis. When an object, and OB the origin, and when an object is at the point A, the time will be t second or t, and the body will be moving with velocity v at the point A. We can draw a normal from the point B on the time axis, and that normal is Bm, and the body will be at the point B at instant of time t plus delta t, where delta t is the small difference in time. We can we can draw a normal from A to Bm, and we can draw a straight line parallel to time axis. And when the body is at the point B, the body will have the velocity v plus delta v, where delta v is very small difference in velocity. The value of AC is delta t, which is small interval of time delta t, and the value of CB is delta v, which is small difference in velocity. Velocity of the body or object increases when it travels from A to B by an amount delta v. Let AI be the instantaneous acceleration. AI be the instantaneous acceleration. Instantaneous acceleration of an object or of a body at the point A. AI be the instantaneous acceleration of a body at the point A at an instant t, or at an instant t second. At an instant t, the body travels from the point A to B, from the point A to B, and its velocity increases from v to v plus delta v. Its velocity increases from v to v plus delta v. Increases from v to v plus delta v. V plus delta v in the small interval of time delta t. Small interval of time delta t. Or small time interval delta t. Therefore, the instantaneous acceleration of the body at the point A, the instantaneous acceleration of the body the instantaneous acceleration of the body at the instant t is given by ai equal acceleration is always rate of change of velocity with respect to time, change in velocity by change in time. ai equal limit delta t tends to 0 delta v by delta t, where delta v is small change in velocity and delta t is small change in time or small interval of time. So we get ai as lt means limit delta t tends to 0 delta v by delta t, where limit delta t tends to 0 indicates that small interval of time or interval of time delta t is very small, not only small, very small, tends to 0, where delta v by delta t, total change in velocity by total time, is the average acceleration, total change in velocity by total interval of time is average acceleration of the body during that small interval of time. Average acceleration of the body. In the small interval of time delta t, small interval of time delta t, this is not very small interval of time for delta v by delta t. Therefore, the instantaneous acceleration of the body at an instant of a body, this is the definition, first definition of instantaneous acceleration. The instantaneous acceleration of a body at an instant is defined as the limiting value of the average acceleration, limiting value of the average acceleration of the body, limiting value of the average acceleration of the body in small interval of time around that instant, limiting value of average acceleration of the body in a small interval of time around that instant, around that given instant, when time interval tends to 0. That means time interval is very small. Time interval tends to 0. Tends to 0. To 0. So this is the definition of instantaneous acceleration. The instantaneous acceleration of a body at an instant is defined as the limiting value of the average acceleration of the body in a small average acceleration of the body. This is what limit delta t tends to 0 means limiting value of delta v by delta means average acceleration. Delta v by delta t is average acceleration. No need to write this part because denoted by blue color, because it is to explain the concept of limiting value. Limit delta t tends to 0 means limiting value of average acceleration. Delta t tends to 0 means interval of time is very small. Interval of time is not only small, is very small. Is very small. No need to this notation denoted by blue color. This is to explain the concept. Here the time interval should tends to 0. Limiting value of average acceleration of the body around that instant where time interval tends to 0. Now we can find the another definition of the instantaneous acceleration. Also, limit, in place of LT we can write limit delta t tends to 0, delta v by delta t can be denoted by dv by dt. dv is very small change in velocity and dt is very small change in interval of time. Therefore, AI has another expression dv by dt. Because AI is limit delta t tends to 0, delta v by delta t, which is equal to dv by dt. So we get the second expression of instantaneous acceleration, which is AI equal delta v by delta t. Equation 2. And we have to write down the second definition of instantaneous acceleration. AI equal dv by dt. Therefore, and also AI equal ddt of v. AI equal ddt of v. ddt means first order derivative with respect to time, or ddt means first time derivative, and ddt of v means first time derivative of velocity or first order derivative of velocity with respect to time. AI equal ddt of v. We can write down the second definition of the instantaneous acceleration at a certain instant t second. Therefore, the instantaneous acceleration of a body at an instant t second is also the first time derivative or first order derivative of its velocity with respect to time. Velocity of the body. In this case, the spelling of derivative is wrong. It should be derivative, derivative of velocity of the body with respect to time. Now here, how to explain the instantaneous acceleration of a body at an instant. It should be at an instant, and we can correct the spelling of derivative derivative. Instantaneous acceleration of a body at an instant is also the first time or first order derivative of the velocity of the body with respect to time at that given instant. First order derivative of the velocity of the body with respect to time. DDT means first order, first time derivative or first order derivative. First order derivative. Derivative with respect to time. And V means the velocity or instantaneous velocity in this case. Now we can find the third expression of instantaneous acceleration. We shall find the third expression of instantaneous acceleration AI. Also, the instantaneous acceleration also the instantaneous velocity of the body at an instant of the body is given by V equal to ddt of S, where S is the displacement. Therefore, AI has the expression ddt of V. Now, in place of V, we can write ddt of S equal ddt bracket first bracket or third bracket opened. In place of V, what we can write ddt of S, where S is the displacement. So ddt of ddt means d square by dt square, d square by dt square of S. So we get the third expression of instantaneous acceleration, which is AI equal d square by dt square of S. AI equal d square by dt square of S means instantaneous acceleration is the second time derivative of displacement. Equation 3. So this will be the third definition of the instantaneous acceleration. Thus, the instantaneous acceleration instantaneous acceleration of the body at an instant is also defined as the second time derivative is equal to the second time derivative or second order derivative of displacement of or the position, second order derivative of displacement or position of the body, at the instant, at the given instant, at that given instant. Here also you have to write at an instant. So we get the final definition of instantaneous acceleration. The instantaneous acceleration of a body at an instant is equal to the second order derivative of the displacement or position of the body at that given instant. Displacement or position of the body with respect to time at that given instant. At that given instant. So we get AI equal d square by dt square means second order derivative or second time derivative second time derivative, and this is the displacement or position of the body at the final position. AI has three expression. First expression we have derived, which is limit delta t tends to 0, delta v by delta t. Another expression AI has, which is ddt of v. Last expression of instantaneous acceleration is AI equal d square by dt square, which is second time derivative, d square by dt square of s, means of displacement. These are the three expressions. We can denote AI equal limit delta t tends to 0, delta v by delta t, then AI equal ddt of v, and third expression is AI equal d square by dt square of s, AI equal ddt of v. Third expression is AI equal d square by dt square of s, means second time derivative of displacement. And we can write down the vector expression of the instantaneous acceleration. AI equal vector AI equal ddt of vector v, where vector v is the velocity vector, and vector AI has another expression which is d square by dt square of vector s, where vector s is the displacement vector.